Jai Hind everyone. I, Dr. Prashan Assistant Professor in Electronics and Communication Engineering Department at Ajay Kumar Garg Engineering College, Ghaziabad, going to discuss a topic, multiple access for packet radio system. This topic is basically related to wireless and mobile communication subject. The code for this subject is BEC 071 and this course is designed for the BTech final year Electronics and Communication Engineering student. So, before we start this random access protocol or random access model, first of all, we should know about multiple access technique. So, in multiple access technique is a technique in which various users utilize a common communication resource, that is communication channel. We already know that in communication there are two primary resources, power and channel bandwidth, and these primary resources must be utilized efficiently because these are precious for our transmission. When we talk about communication channel, we have limited communication channel availability, and for efficient utilization of this communication channel, we must share this channel among the various users so that this channel can be properly utilized, because the generation of information from the individual is very low as compared to channel bandwidth. When we distribute this channel among various users, then only we can utilize the channel properly. So, multiple access techniques basically provide a mean for utilization of channel by uniformly distributing the channel resources among various users. As we know that there are multiple access technique, various multiple access technique like frequency division multiple access, time division multiple access, code division multiple access, and space division multiple access, so on. Similarly, we have also another technique, random access. So, when we talk about random access, which is also known as contention method, in this method there is no station is superior and no station allow to control another station. No station permit or does not permit another station to send. The station has own control to send the information. At each station, a station that has data to send uses a procedure defined by the protocol to make a decision on whether or not to send, because in modern communication we are using packets for the data transmission. So, this random access protocol is used for transmission of data from one node to another node or from one station to another station. So, in this random access protocol, no station is superior, no one is inferior. A station has to decide when it has to transmit data under the certain protocol. Before we go on more deep in random access, we must know about the layered protocol. In layered protocol, we see the OSI model, and according to OSI model, we have the first lower layer is physical layer, and this physical layer is solely responsible for actual physical transmission of the packet. In this physical layer, we choose the modulation scheme, bitrate, synchronization method, and this layer is responsible for the actual transmission of packet over the physical channels. The issues concerning packet access control are handled by data link layer, and data link layer is responsible for node to node, flow control, error correction, and access control. Further, the data link layer is subdivided into two layers. The first one is known as MAC layer, which is the medium access control layer, and the upper sublayer is known as logic link control layer. So these two layers are important when we talk about our random access system. When we talk about multiple access protocols, so in random access, multiple access protocol, we have random access protocol, under which we have Aloha, SISMA, SISMA CD, and SISMA CA. Controlled access protocol, we have reservation, polling, token passing, and in channelization protocol, we have FDMA, frequency division multiple access, time division multiple access, and code division multiple access. So in this presentation, we will discuss about Aloha, SISMA, SISMA CD, and SISMA CA. So first of all, we will discuss about Aloha, the most familiar part of the random access. We have two kind of Aloha. One is known as pure Aloha and another is known as slotted Aloha. In 1970s, the University of Hawaii developed a packet radio network. In this Aloha, a sender may transmit a packet at any time, and it assumes that there will be no collision occur. S finds out whether transmission was successful or experienced a collision by listening for an acknowledgement broadcast from the destination station. If the sender receives an acknowledgement signal from the receiver, then it assumes that the transmission was successful within a time. And if the sender does not receive an acknowledgement within a fixed time, it assumes that there was a collision, and due to this collision, the packet was lost and the packet was lost. If there was a collision, then S retransmit after some random time. This is shown in this figure. Here we have certain mobile stations like 1, 2, 3. First, suppose sender 1 want to transmit a packet. It sends its packet, and in this instant there is no another transmission, so its packet will transmit without any collision. But here we can see that these two stations, station 2 and 3, both are transmitting at the same time, then there will be a chance of collision and there will occur a collision, and due to this collision the packet will lost. And in this scenario, each sender 2 and 3 will retransmit their packet because they will not get acknowledgement from the receiver. Further, there also a chance of collision if both the station again retransmit their packet. So in case of pure Aloha, there is a lot of collision probability. In this figure, we can also understand There are 4 stations and each station has to transmit their own frames. Computer 1, station 1 transmitted its frame. Here computer 2 and station 3 both are transmitting. And at the meanwhile, station 4 is also transmitting its packet. So in this region, there is a high probability of collision. And this duration is represented as collision duration. Further, here we have 2 different frames. So here also there is a possibility of collision. We can see that if the duration of a frame is TFR, so 2TFR will be vulnerable time. In this time, there is a chance of collision between the frames. This scenario is also depicted in this figure. Here is the frame B and here is the frame A. When frame B end, but at that same time, if the frame A starts, there is a chance of collision. So, in pure Aloha case, the duration of vulnerable time will be twice of frame duration. If we transmit the frame after 2 TFR, there will be less probability of collision. Now, we will discuss about the maximum output in case of Aloha, which is known as throughput of Aloha. In this derivation, we have assumed that the packet length or duration is T, and the probability that n packets arrive in time 2t will be given by the equation Pn 2g raised to the power n e raised to the power minus 2g divided by factorial n, where g is the normalized offered traffic load for the channel. Now we will get the probability that a packet is successfully received without any collision by putting n equals to 0, and when we put p 0, we will get e to the power minus 2g. For maximum output, when we solve this equation, we get the value of g half, and when we put this g equals to half in the maximum throughput equation, we get this value 0.184. So in case of pure Aloha, the throughput is 0.184 or 18.4%. So as we have seen that in case of pure Aloha, there is a lot of probability of collision. So to improve pure Aloha, another scheme is proposed which is known as slotted Aloha. In slotted Aloha, the time is slotted. The entire time axis is divided into fixed time slot, and the packet transmission can start only at the beginning of a slot. This reduces the collision duration. If in case of pure Aloha, if a packet 1 is almost finished, when it collides with just starting packet 2, the collision can last for nearly 2t, as we have seen earlier. But in case of slotted Aloha, as I told you that the transmission will start only at the start of a time slot. So in case of slotted Aloha, 2 packets can collide only when both are just starting at the same time slot, which we have demonstrated in this diagram. These are the various slots. These are the various slots which we have demonstrated in this figure. And in case of slotted Aloha, the sender transmits its packet only in these fixed slots. So, when packet 1 is transmitted, there is no another transmission, so this packet will be successfully delivered. But in this case, we can see that station 2 and 3 both starts their transmission at the same slot, so there is a collision. And when this occurs, the station 2 and 3 wait for a random time, and after waiting for a random time, they retransmit their packet at different slots. This is also demonstrated in this figure. Station 1 is transmitting in this particular slot, but station 2 and 3 are transmitting in this slot, in this same slot, so there is a collision. Further, here also a chance of collision, but in these slots we have no collision and the frames or data will be transferred without any collision. So, it is clear from this diagram that in case of slotted Aloha, the vulnerable time is only duration of frame, that is TFR. So, in case of slotted Aloha, we have minimizes the vulnerable time. Further, if we want to calculate the maximum output of slotted Aloha, so probability of no collision, when we put n equals to 0, we will get e to the power minus g, and the throughput will be g into p0 and g into e to the power minus g. And when we solve for this equation for maximum value of throughput, the g comes to be 1, and when we put this 1 in this equation, the maximum throughput will be 0.368, that is 36.8%, just double the throughput of pure Aloha. So, by fixing the time slot, we have increases the throughput in case of slotted Aloha. This is the traffic load and throughput curve which demonstrate the efficiency of slotted and pure Aloha. We can see that the efficiency of slotted Aloha is more than the throughput of Aloha. Now we will discuss the difference between pure Aloha and slotted Aloha. We have earlier seen that in pure Aloha, the packet can be sent at any time, but in slotted Aloha, each station can send the data at the provided time slot. In pure Aloha, the time is not globally synchronized in this Aloha, while in slotted Aloha, the time is globally synchronized because we have truncated the time slots. Pure Aloha is a continuous time, but slotted Aloha is discrete time. Vulnerable time is twice of frame time, but in slotted Aloha, it is frame time. The maximum throughput is 18.4%, whereas in case of slotted Aloha, it is nearly 37%. Pure Aloha does not reduce to half the number of collision, while slotted Aloha reduces collision number to half, therefore double the efficiency. Next, we will discuss about SISMA, which stands for Carrier Sense Multiple Access. In this protocol, we obtain better throughput than Aloha by avoiding collisions. In this SISMA protocol, the sender first sends the channel for the carrier before transmitting a packet. If the channel is busy, then it does not transmit, but if the channel is ideal, it transmits its packet, which is shown in this figure. Here, the station 1 senses the channel. If channel is ideal, then it transmits its packet. Again, station 2 senses the channel is free, ideal, then it transmits its packet. But When the two stations senses the channel and both are getting ideal channel and they start their transmission at the same time, there will be a possibility of collision. In this case, the packet will collide and we will not get data at the receiver side. This carrier sense multiple access protocol avoids some collision but not at all, which is shown in this figure. Here we don't have any kind of collision while transmitting packet 1, 2, 3, but when we comes at this situation, we have a collision. When we talk about SISMA protocol, the SISMA protocol is further divided into non-persistent SISMA and persistent SISMA. Further, the non-persistent SISMA is divided into unslotted and slotted, and persistent SISMA is also divided into unslotted, slotted, and one persistent SISMA and p persistent SISMA. When we talk about persistent method, so first we will talk about one persistent method. In this method, the sender continuously senses the channel, and if it is ideal, then it transmit, otherwise it continuously senses the channel. This is also demonstrated in this figure. The station senses the channel. If it is busy, it continuously senses the channel, but if it is ideal, then it transmits the packet. In non-persistent method, the sender senses the channel. If the channel is busy, it wait, again sense the channel, and if the channel is busy, then it wait, but at this time it increases its waiting period, and if the channel is free, then it transmit its packet. In this way, senses the channel. If ideal, the station can transmit. If it is busy, it wait a random time, and after a random time, it again check the channel whether the channel is busy or not. But in case of p persistent SISMA, the sender senses the channel, and if it is busy, it continuously senses. But if the channel is ideal, if the channel is free, the sender can send the packet with a probability of p like this. The channel is sensed. If it is busy, it continue to sense, but if it is ideal, it may transmit packet with a probability of p, and it may wait for its slot which have a probability 1 minus p, like this. If the medium is ideal, transmit with probability p, or delay with next time slot with probability 1 minus p. If transmission was delayed by one time slot, we have to go again with step 1. If the medium is busy, continue to listen until the medium becomes idle, then go to again step 1. So, p persistent SISMA is a good trade-off between non-persistent and p persistent SISMA. So, this is the all about SISMA protocol. These are the references which I have used while preparing the presentation. Thank you.